Hi guys, there were a couple of questions from section 3.4. So the first one was number 13. Let me write the function, then I'll tell you, I'm sure by now you know the question, so let me just kind of explain to you what's the process for these problems. So we have f of x is 1 plus 6x minus 3x squared, and we are basically restricted to the closed interval 0, 4. Okay, so the question is for us to find the absolute maximum and minimum value of this function over this closed interval. So there is a theorem, I'm sure in the section that you read, that says that every continuous function will have a absolute maximum minimum on a closed interval. The question, of course, is how do you find them? So here is the deal. There are two types of places that absolute maximum minimum can happen. In other words, two types of x values. Either the critical values or, of course, the endpoints. Always remember the endpoints, which are in this case 0, 4. We call them the endpoints of the interval because they kind of show up at the end. So you always have to consider the function at the endpoints, but you also have to look for the critical values, because there's only two places where the absolute maximum minimum can happen. So let's just start looking for the critical values. I'm sure you know by now to find the critical. By the way, the critical values you find, you only worry about the ones that are in this interval. In other words, if your critical values is less than 0 or more than 4, you don't have to worry about it. You only worry about the critical values that lie in this interval, right? So there must be always between the value of 0 and 4. So in this case, our derivative is, of course, 6. As you know, derivative of 1 is 0, and derivative of 6x is 6, and derivative of 3x squared, of course, is 6x. So we're going to look for the critical values, which, of course, by setting that equal to 0, move the 6 over, and then, of course, divide by negative 6. So the only critical values that we do get in this case is number 1. And if you notice, 1 is between 0 and 4, which means we do have to consider 1. So there's only, so this is pretty much almost over. So once you find your critical values, again, you only care about the ones that lie in the interval. You're going to evaluate your original function, not the derivative, original function at that critical value. Also, you don't forget, you always have to include the endpoints. So you also have to include f of 0 and f of 4. Now, once you compute these, whichever value is the largest, that's your absolute maximum, and whichever are these three values the smallest is the absolute minimum. So that's it. So it's actually pretty straightforward type of process here, but again, make sure, of course, you do include the endpoints. So as you plug in 1 in the original function, that becomes 1 plus 6 times 1 minus 3 times 1 squared. And as you do the arithmetic there, that should end up to be 4. Also, f of 0, as you plug in 0 in place of x, that's 1 plus 6 times 0 minus 3 times 0 squared, which, of course, turns out to be 1. And then f of 4, again, going back to original function, replace all the x's with 4, which, of course, after, again, you do your arithmetic there, you should get negative 23. Okay, so now we have the three values that we have to find. So as you can see, between 4, 1, and negative 23, of course, the largest is 4, so that's your absolute maximum. And, of course, the smallest is negative 23. But let me just make sure you know how to finalize the answer. So I'm just going to go up here. So this is the way. Once you do all your computation, here is how you finalize the answer. So we'll say absolute maximum equals, so we know, of course, it's 4, but you also have to tell them or tell us where it's going to occur. And, of course, it occurs at x equals to 1. So we just say at x equals to 1. And then also, since negative 23 is the smallest value, that will be your absolute minimum. So your absolute minimum is negative 23. And, of course, that happens when x is 4. So we'll just say at x equals to 4. So this is truly the conclusion for this problem. Of course, we have to go through the process to get there, but there is your conclusion for this problem. Okay, so I think this one is so let me go ahead and stop this one. So the next problem is same question except different function. So it may get a bit too long for both of them to be the same video. Okay, so I'll make another one for the next problem.